Hello, everybody. So this is the last day of the polynomials unit before review starts. And really, it's just kind of reviewing and practicing. I'm not going to take up too much time. In class, we're going to do this partner chart, and I think that'll be good. So let's start with some bell work. And our bell work today is 1, find f of -2 given that f of x equals 4x to the third plus 2x squared minus 5x plus 10. But wait, we're not done. Using synthetic substitution. Okay, so how do you use synthetic substitution? Remember? No, you don't. Oh my God. And that's why this problem is here. Because you can't lose this knowledge just 4 days later. Review your notes. Think about this stuff. Otherwise, the test is going to be so hard. You can't cram all this knowledge. You have to learn this material. Okay? So, synthetic substitution, that's where we take this -2 and do 4, 2, -5, 10. This is not a factoring problem. I'm not asking you to factor this. Do not use factoring by grouping here. I want to know what f of -2 is. Don't put a -2 into each of the x's. That's not synthetic substitution. I want synthetic substitution, which means we use synthetic division with that given x value. -8, -6, +12, +7, -14, -4. So I know f of -2 equals -4. And you know what I'm going to know? I'm going to know who watched this video or not, because the people who watched the video are going to be able to do this problem on the test, and the people who aren't watching this video, they're just going to have no clue what synthetic substitution is. They're going to plug a 2 in for each of those x's, and all of us are going to be sad when the problem is wrong. So, please, synthetic substitution. Okay, given f of x equals 6x to the third minus 29x squared minus 17x plus 60, show, this comes in parts, show that x minus 5 is a factor. Okay? How do I show that this is a factor of this cubic polynomial? Well, give it a try. Come back when you're ready. Yes, you could use long division. I, though, am a big fan of synthetic because I'm wicked lazy and don't want to spend any more time doing this stuff than I have to. So, 6, I multiply 30, I add 1, 5, -12, -60, 0. The factor theorem says when I get a 0 remainder, then that's an x-intercept, which means that's a factor. So I can show that x minus 5 is a factor because when I do my synthetic division, I get 0. When I do my long division with this, if I did long division with this, I would also have a remainder of 0. And that could be another way to show it. In fact, why don't I just do it instead of talking about it? 6x to the third minus 29x squared minus 17x plus 60. Hey, did you think about 0 placeholders? You got to be thinking about 0 placeholders. Okay, what do I multiply this by to turn into this? How about 6x squared? 6x to the third minus 30x squared, and then we subtract. Minus 29 minus a minus 30 is plus 1x squared. Don't forget to bring down the -17x. What do I multiply this by to turn it into this? That's going to be x. So I have x squared minus 5x, and then I subtract. And so this is minus a minus or plus. Minus 17 plus 5 is minus 12x plus 60. What do I multiply this by to turn into this? I need a -12. And when I distribute that -12, I get minus 12x plus 60. and when I subtract, a tiny, tiny 0 off the end of the board. All right, because I got a remainder of 0, I know that this is a factor of that polynomial. Okay, now part B is find the complete linear factorization of this polynomial. Well, luckily we know that 5 is, in fact, one of the x-intercepts. And if I only knew about long division, I'd be very sad right now because I'd have to do all that long division over because I erased it. But here I'm going pretty quick, kitty quick, and I get 0. So this was third degree, this must be second degree. Oops, x. And now I need to factor. So again, if you're not comfortable factoring this with guess and check, that's okay. But you really need to be able to factor this and not crawl under the desk and say, I can't. Go back and watch those factoring, the factoring videos from the Algebra Basics unit. Okay, so let's see what we can do. You know what might be smart of me? Why don't I just show you that method that I highlighted in the video. I'm looking for the factors of negative 72, a times c, that add up to positive 1. Okay, how about 9 and negative 8? These multiply together to be that. These add together to be that. So I'm going to replace this one term with those two terms. Okay, so I've got 6x squared plus 9x minus 8x minus 12. Now I have 4 terms, so I can do factoring by grouping. Don't forget to capture this inside there. So we've got 3x, 2x plus 3. I pull out a negative 4 here. I get 2x plus 3. Because this is common to these two terms, I can pull that out. So I've got a 2x plus 3 that I'm taking out. What's left? A 3x. What's left? A minus 4. So there's my factored form. Oh, but wait, that's not the complete factored form, is it? These are only the remaining factors. Don't forget, we needed that one as well. Now this would FOIL out to a cubic. Okay. Okay. C, or 3. Here's our third problem. F of x equals x to the third plus 2x squared minus 3x minus 6. X equals root 3 is a root. Find all the zeros. Okay, find all the zeros for this third degree polynomial. Come back when you're done. Okay, so I'm dying to know who did synthetic division with root 3 and negative root 3, and who used factor by grouping and then setting that x squared plus minus 3 factor equal to 0. Sometimes that works. You could certainly do that here, but not all the time. So I want you to be able to do this. 1, 2, negative 3, negative 6. Okay, I bring down the 1, I have root 3. I can't add those except by saying this. I need to distribute that to that and that to that. And look, you really need to know at this point that when I'm doing root 3 times a root 3, that's going to be a root 9. And you know the square root of 9 is 3. So stop looking at this like you don't know how to do it, because you do know how to do it. Okay? So we're going to have 2 root 3 plus 3. And then when I add, this negative 3 and positive 3 will cancel, and I'll just have 2 root 3 here. When I multiply root 3 times 2 root 3 times root 3 is 3, times 2, I get 6. Great, that's a remainder of 0, so this is one of my roots. And I know that irrational roots always travel in conjugate pairs, so now I'm going to use negative root 3. Oh, and how convenient. They cancel, and I'm left with 2, and I multiply, and this becomes 0. So there it is. So our factored form or our zeros? Our zeros, we're looking for zeros, not factored form. X equals plus and minus root 3, and x equals 2. These are our negative 2, right? Because we would write x plus 2. That's the factor. And the 0 is negative 2. Okay, and I guess that means you should really pay attention to the details. Like, are we looking for the zeros? Are we looking for the factored form? Are we looking for all the factors? Or are we just looking for the remaining factors? So please make sure you're paying attention to the language. Okay, next, this will help when it comes time to do that partner chart. So let's say our f of x is x to the fourth minus 5x squared minus 36. So can you factor this? Well, sure you can. Look, this fits the same form as this. And this factors as x minus 9 and x plus 4, right? Minus 9 plus 4 is minus 5. Negative 9 times positive 4 is negative 36. So I want to use this to help me factor something that has the parallel structure. Instead of having x's in each of these spots, I'm going to have x squareds in each of those spots. Okay, so now we've got this factored with some quadratics, but we can take this further, right? We can factor as x minus 3, x plus 3, and x squared plus 4. Now, this is factored with real numbers. I only see real numbers here, which is great, but, you know, Kukla always wants linear factors, so I got to do something with this. Now, again, a lot of people aren't comfortable with that as a difference of squares because they see the big old plus sign. So remember, what we're supposed to do is set this factor equal to 0. And so we'll have x squared equals negative 4. We'll take the square root of both sides, and so x is going to be plus and minus 2i. If you're not comfortable with that plus and minus 2i, you might want to go back and watch one of the earlier videos because that's something that we're supposed to be comfortable with. So my complete linear factorization, these factors from here. Now what about these factors? Those are my complex roots, so we've got x minus 2i and x plus 2i. And there's our fourth degree polynomial fully factored, okay? We've only got 2 real x-intercepts, and we've got these 2 imaginary x-intercepts. Okay. How about this one? Y equals 8x to the third minus 27. I'd like you to factor this. No, there's no GCF factoring. Yes, this is a difference of cubes. Yes, you do need to memorize this process for factoring a difference of cubes. So, it's always a binomial and a trinomial. In the binomial, we have this and this sign and this. And here, this goes here squared. So 2x squared is going to be that. And here goes this one squared. 3 squared is 9. And the middle term is simply this times this, change the sign. Since that's a minus, this has to be a plus, and 6x. There's our factored form. Now this produces only one real x-intercept at x equals 3/2. And that shouldn't surprise us, because think about this from the transformations point of view. It's got a vertical stretch, and it's shifted down 27. So, how many x-intercepts do you see? That's right, just this one over here, and that's at 3/2. Okay, only one real x-intercept. But if you're asked to find all the roots of this polynomial, then 3/2 is one of those roots, but this contains 2 more. Remember, from our linear factorization theorem, we know that this thing can be broken down into linear factors over the complex number system. So I have to factor that. I'm quiet because I feel like, shouldn't I be able to factor that? 2x plus 3, 2x plus 3. Oh, 6x, 6x, that would be 12x. So no, that's not going to factor that way. And it's not supposed to factor. It's supposed to be no real solutions here. We're supposed to use the quadratic formula here to find them. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so 16 times 9 is 144. 36 minus 144, is that negative 12? Negative 112. 48. No. Damn. All right, I'm pulling out a calculator. So we've got 36 minus 144, negative 108. All right, there we go. That's under my radical, so I have negative 6 plus and minus square root negative 108 over 8. Well, can't leave that like that. Keep going. So that's going to be square root of negative 1 times square root of 108. 108 is 12 times 9. So 9 times 12, that's 3 times 3 times 3 times 2 times 2. Looks like I can take out a 2 and a 3. Looks like this is going to turn into an I. So I have 6i on the outside and a 3 underneath the radical. So let's get rid of this, and let's put 6i root 3. Now, can I cancel out a 2 this way? No, you can take out a 2 from everything, but it has to come out from everything. So negative 3 plus and minus 3i root 3 all over 8. These cancel, leaving me 4. So what are all my zeros? Well, I'm sorry, complex roots. So here are 2 of them. And here's the third one. All right. Okay, well, if you need more practice with any of this, let me know. Our textbook has lots of problems to play with. And certainly, if we don't finish the partner chart in class, you should do that partner chart. There's some good problems in that. All right, surprise, short video. Hope you have a great